We now have to face the most important curve probability distribution for, well, the rest of the course and for all introductory statistics students, i.e. the normal curve. So the first thing we need to do is figure out what the normal curve looks like. So I wanted you to remember from chapter 6 that James Bernoulli, who's the guy who thought of the properties of a binomial distribution, and Abraham de Moivre started studying the binomial distribution at great length. And they noticed that, for example, there's a difference here when p was equal to 0.5. So when it's kind of a middle of the road number, like from 0.4 to 0.5 to 0.6, somewhere in there, the bars on a histogram would form this shape. See it? And then they noticed that even if they had a very skewed distribution, i.e. p was 0.2 or 0.8 or something like that, really off on the edges for a binomial, but n was really large, they would find this curve kind of thing happening. It's the same curve shape that they saw up here. Carl Pearson would later coin the phrase normal for this curve that they had found. And so it's called the normal curve, aka, i.e., the bell curve or the bell-shaped distribution, that kind of thing. All right, so let's look at what a normal curve takes. So a normal curve is a continuous random variable, is normally distributed if the relative frequency histogram follows this shape. Okay, the inflection points are where the standard deviation happens. So here's where the first standard deviation is. Here's where the first standard deviation is on the left side. And it's where it kind of changes. Like in between, it's kind of bowl-shaped down, called concave down. And then over here, it's concave up on the edges, and same over here. So it's concave up on the tails, concave down in the center, and the point where it switches in between those is called the inflection point. I mean, if you ever take calculus, that's where the second derivative is equal to 0. But if you never take calculus, don't worry about it. It's where you'd be skiing the fastest. So if you imagine this like a roller coaster, you'd be stopped up here, and then you go down, 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 fast, 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 fastest, and then start slowing, 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 right? All right, now what are the properties of this curve? It is symmetric, right? So it's like mirror imaged. The mean, the median, mode are all at the center peak. It has inflection points, which I just explained. One standard deviation to the good and one standard deviation to the bad, or high and low. The area under the entire curve is 1, well, because it's a probability curve, right? And we learned in chapter 5 that probabilities have to add up to 1, so that's why property 4 is there. Since it's symmetric and the whole thing makes 1, that means each half is worth a half, which is what step 5 says. Property 6 says, as it increases without bound, it gets larger and larger, blah, blah, blah. What they're talking about is asymptotes. It actually gets closer and closer and closer to the x-axis, but it never stops, and it never crosses or touches the x-axis. It's called a horizontal asymptote, if you ever learned that in school. Right? And then this part right here is the 68, 95, 99.7 rule we learned way back in chapter 3, the empirical rule. But that's not going to become very important to us because we're going to get more precise than that is in this chapter. All right. So let's look at these ones. Now these are two curves that have the same standard deviation but different means. You can tell they have the same standard deviation because they have the same shape. And by shape I mean skinniness. I don't know if that's a word. Fatness. I don't know if those are real words, but bear with me. Right? And then they have different means. You can tell that because the centers are at different places. So now my question is, what is the standard deviation and what is the mean for each one of these? All right, so the standard deviation would be 1. And the mean for this one, okay, let me write it down. Mean for pink is 0. The mean for blue is 3. And the standard deviation is 1 because 3 and 4 are 1 apart. 2 and 3 are 1 apart. 0 and 1 are 1 apart. Negative, right? So the standard deviation is 1 for both of them, but the means are different, 0 and 3 respectively.